Okay, for our first talk, someone described him as the guy with a funny shirt. The talk is entitled JRuby 9000. Please give a round of applause to Charles.
All right, give me just a second here. Okay, I think we're live. All right, hello, good morning everybody. Good morning. Had a great time at karaoke last night. How many people went to karaoke? Oh, awesome. I thought it was going to be all the hands down because the other people are the ones that aren't here. That's awesome. Very excited to be here to talk through a little bit about JRuby 9000, why we're really excited about it, and hopefully why you will be too. There. So who is this guy in the obnoxious orange shirt? I'm Charles Nutter. You can call me Charlie. That's what my friends call me. At Hedius on pretty much every service that's out there. You should be able to find me pretty easily. I am from Minnesota, northern United States, about 6 hours drive north of Chicago. The picture of the snow-covered tree is from today. So this is in April now, and we're still getting snowfall there. But I live in Minneapolis. It's a very lovely city. Nice summers, so it balances out pretty well. I mentioned yesterday I'm also a gamer, so if you're on PlayStation Network, PS4, I'm a big fan of the Dark Souls series, Bloodborne as well, I mentioned. And if you haven't tried it out, there's a game called Salt and Sanctuary, which is like a 2D Dark Souls. I've been having a lot of fun with that. So a little bit more practical, interesting information. I work at Red Hat. Red Hat has graciously sponsored JRuby development for the past 4 years, paying 2 of us to work full-time on just JRuby. And then also a lot of travel, going around the world to meet folks like you. Very excited to be here. It's my first time in the Philippines, and I've managed to meet and talk to a lot of great folks. And you know, I realized just recently that I've been working on JRuby for 10 years now, full-time. First at Sun Microsystems. Thank you. I didn't expect to make a career out of working on JRuby, but that's kind of how it's gone. So at first at Sun Microsystems, and then later on at Engineered for a little while, and then we moved to Red Hat. We kind of settled in there to a polyglot language group that's there. And obviously, if I'm spending 10 years working on JRuby, I must love Ruby. I really do love this language. I want to see it succeed. I want to see it continue to be popular. And I want Ruby to be everywhere. I don't want people to have to leave Ruby to get concurrency and performance and whatnot. And I believe JRuby is the way that we can keep Ruby really vital. For large-scale applications, for applications that need more concurrency, need better performance, that's where JRuby fits perfectly, and hopefully we'll be able to show you that today. So, how many people want a faster Ruby today? Yeah. Okay. Good. How many people would like better? I don't know what this thing's doing. How many people would like better concurrency, better parallelism in Ruby today? Of course. I mean, these are things that we want. So, how many people here actually use JRuby? There's a couple folks. I've managed to talk to a few of you. Not nearly enough. Not nearly enough. So we'll try and convince you today. So let's talk a little bit about JRuby itself. So for how many people? Hopefully most people are familiar with JRuby at least. How many people have never heard of JRuby or never really looked into it? Okay, so most people are roughly familiar with it. We'll continue on here. So JRuby is basically what you love from Ruby. It's got all the latest features. We're about to do a release that has Ruby 2.3 support. Current release supports Ruby 2.2, so we're pretty much caught up in compatibility, finally. We use basically the same standard library, the same Ruby gems that are out there all work just like they do on regular CRuby. We have some native gems of our own, so for gems that have a C extension, we don't support that API, but most of the time there's a JRuby version as well, Geary, Site, and so on. So usually you're not going to have too many issues if you're making a migration. If you do, and there's a popular C extension library out there, you let us know. We'll work with you to find a replacement or get a JRuby version of it. And the bottom line, though, is that this really is just a Ruby implementation. My biggest pet peeve is hearing from people that don't want to use JRuby because they don't like Java. And I gotta get it across that it's not Java, it's Ruby, where it's like Ruby taking over Java's virtual machine, basically. So you don't have to be a Java developer, you don't have to know how to deal with Java or the ecosystem. It's just a Ruby implementation that leverages the JVM. And along with the JVM comes a lot of power. We have the first native JIT for Ruby code. So code that runs in JRuby will eventually get down to actual assembly code and optimize and inline. All the cool stuff that the JVM does for Java, it does for Ruby as well. Fully parallel threading. You do thread.new, that's a system thread. It can run right alongside the other ones. You can saturate an entire machine, all the cores, with one JRuby process. The best garbage collectors in the world are available on the JVM. Basically so good that garbage collection is not going to be your problem if you use JRuby. It's just not. And then of course all the other languages and libraries that are out there. There's tens of thousands of libraries, dozens of languages that you can just use from Ruby in JRuby. You can call out to Java libraries, Scala libraries. You can combine Ruby enclosure in an application. And it all just fits together really nice. But all of that, still just a Ruby implementation. Still all of what you expect from Ruby. And you may never, if you look at code for JRuby, you might never even know that you're not running on CRuby. We've been very happy and been very lucky to have a lot of excellent users over the years. A couple of years ago at RubyConf, I asked for all of the companies that are out there that use JRuby and would like to have a logo on our slide. This is 1 day's worth of replies. And it was dozens of companies, a lot of places that I didn't even realize. BBC News, all of the election results that they show for any elections, any major elections, national elections in the UK, it's a JRuby app. Visa has some new payment systems that are running on JRuby. Let's see, what else is on here? Oracle has the Java.net site, actually is a JRuby on Rails application. Wild, huh? It's amazing that all this stuff is out there. NASA. One of my favorite users is the SETI project, the Search for Extraterrestrial Intelligence. The Allen Telescope Array, one of the largest radio telescope arrays in the world, uses lots of languages, but JRuby coordinates. So JRuby is actually helping to find extraterrestrial life. So cool. And then, of course, there's scary ones, like Oslo's International Airport uses a JRuby-based terminal for jet refueling. It's like, I don't want to know about that. That's your deal, man. And those guys did a great job testing it, but every time I fly through Oslo, I'm like, I really hope JRuby works today. So we've been hearing a lot about Ruby 3. Mons has been talking about working on performance, going to be at Ruby 3 times 3 times faster than Ruby 2.0. There's going to be something for concurrency, maybe not just straight up parallel threading, but maybe some actor system, maybe some memory isolation, something like that. So these are things that are coming up. The problem is whenever he's asked about when this is going to happen, it's going to be a little while. So we're going to have to wait for maybe 5, maybe more years to actually get these promised performance improvements and concurrency improvements. And so the folks that are out here right now doing Ruby development need something today that can be better for their applications. We're trying to scale stuff up, right? We all want to be the next Twitter or Facebook. And we need a better Ruby runtime to be able to get there. So let's talk a little bit about performance. So there are a lot of things that we can optimize for in an application. We can optimize for development time and programmer happiness, and Ruby already pretty much does that very well for us. So that applies to JRuby and CRuby alike. You can have fast startup, and CRuby is bar none the best at this. just a bare CRuby runtime will start up in under 1/10 of a second. I mean, ideally, it's milliseconds to get a regular CRuby implementation going. This is an area where we suffer a little bit. We do more optimization, we've got a larger runtime to boot, so we're a little bit slower at that. Just full disclosure on that. But then there's straight line performance. How fast can you actually just churn through work? JRuby does extremely well there, and parallelism, of course, there's really no parallelism in CRuby without forking, without multiple processes. JRuby has a great story there too. So let's talk about the production quality Rubies that we have today. And by production quality, these are some of the requirements that I would put on that list. So you have to have support for a high level of Ruby features, like 99% plus. We're definitely there on that. Like I mentioned, we're going to have a Ruby 2.3 release, or Ruby 2.3 compatible release, probably in the next month or so. You need the important parts of the standard library. And by the important parts, I'm like, maybe not the TK toolkit stuff, maybe not the unusual Unix database support, but all of the key libraries that you typically will use in a Ruby application, we've got on JRuby. You've got to be able to run the applications that people use. There's lots of Rails applications out there, Sinatra applications running on JRuby. They work great, they scale really well, we're good in there. Healthy extension ecosystem. We've worked with people to have all of those C libraries have a JRuby version, a Java version, so that's good too. And by these criteria, really CRuby and JRuby are the only production quality Rubies right now. So you're going to be using one of these two, and hopefully as your application grows, JRuby will be a good fit for you. So let's talk about CRuby as far as performance, straight line execution. So up until 1.9, it had an interpreter that basically walked the syntax tree. Just very similar layout in JRuby early on in its time. Just walked through and said, okay, it's a call, it's got a fixed num, plus another fixed num, let's do that, and then it went from there. Ruby 1.9 improved that by adding a bytecode in VM underneath it. So the AST was translated into a flat set of instructions, there's a stack, there's local variables, similar to how the JVM works. So it was able to have much better performance in a lot of cases, and a little bit better use of the stack, use of memory as well. In the 2.x series, we started to see a lot of GC and straight line performance improvements as well. I've got some numbers a little bit later. Really excited to see what Koichi and Nobu and Mats and everybody else are doing to improve Ruby core and get better performance for the folks that are on CRuby. I mentioned Ruby 2.3, and there's continuing work on JIT and GC. Obviously, if they're going to get to 3 times faster, there's a lot of work that needs to be done, even in the course of 4 or 5 years. So JRuby, we've had many redesigns since we were actually started in 2001, long before I got into the project. That was Ruby 1.6 timeframe, like 1.6.8 I think was what the first JRuby release was compatible with. So we also had an AST-based interpreter up until about 2007. And now with JRuby 9000, we've taken a similar approach. We've come up with our own instruction set, we've got our own VM that runs on top of the JVM, allows us to do a lot better optimizations. We've also been working with Oracle Labs on a next generation runtime called JRuby plus Truffle that shows really interesting performance characteristics, 10, 20 times faster than JRuby today. Hopefully in the next couple of years that'll be an option for you. But I'm talking about real world stuff for real world users right now, today. And of course there's lies and there's damn lies and there's benchmarks and they all suck. But I'm going to talk through a few benchmarks that are hopefully not too trivial, they're not too small. They might represent some real world work that you're going to do in an application. So here's CRuby performance on a red-black tree. And the performance of 1.8 there up at the top, this is higher is worse, so more time to run the benchmark. It's taking longer. And obviously the big jump there is from 1.8 to 1.9 when the new VM came in. We'll cut out 1.8 and 1.9 here and just look at the 2.0 series. And there's been a little bit of improvement in performance on this particular benchmark over time, but not a great deal. It's not moving particularly fast as far as straight line performance on an object or object graph, memory walking sort of benchmark. And then we have JRuby. So this is JRuby 9.1 versus CRuby. And there's 2 aspects here that are interesting. Looking at the early part of the graph, here's the startup time stuff that I mentioned. Takes JRuby a little bit of time to warm up. We analyze your code, we do optimizations as it runs, the JVM does the same thing, so it will take us a little bit longer to get going, especially on a large application. But once we actually do get going, we really scream. We really move stuff along. And this is a pure Ruby red-black tree implementation. It's creating a giant graph, it's walking the whole thing, deleting, searching, all sorts of stuff. And roughly 4 times faster than CRuby today on this particular benchmark. And I think this is a fairly good representation of what Ruby performance can be in JRuby. So how do we get there? I talked a little bit about our internals. So JRuby today takes your Ruby code and it will then proceed to parse that into our JRuby AST. Now, prior to JRuby 9000, we would stop at that point and just interpret that AST. And in the early days, JRuby 1.0, that was all there was. We didn't have a compiler or a JIT. But in JRuby 9000, we proceed on from there. We take the AST and we turn it into our internal representation, our bytecode format. And this is like a standard computer science 101 sort of compiler. If you've ever taken a compiler's course, you can come in and help us write optimization passes. You'll understand the structure of this thing. Gives us a better opportunity to optimize before we give the code to the JVM. It's given us a lot of opportunities now. And then the JRuby IR eventually proceeds on and turns into JVM bytecode. Ideally, we've done the right kind of optimizations. The JVM can take it from there and do all the rest of the magic, turning it into native code and inlining stuff for us. So what kind of stuff can we do with this? Well, we've been working on a number of different optimizations since we got JRuby 9000 out. I'm going to show a few things that we've managed to do because of our new runtime and our new compiler. So one of the earliest ones, and I'm really excited about this one, block pass-through. So you've probably seen this pattern in code. Some block wants to be passed through multiple levels of calls. You don't necessarily care about the block in the foo method, but you want to pass it down through to the bar method. Used pretty heavily within Rails, used in a lot of standard libraries. Most people have written some of this code sometime in their life if you're doing day-to-day Ruby development. Now the problem here is that when you capture that block up at the top here with the foo ampersand b here, normally you would have to create a proc object to wrap it. Rather than just having the implicit block there, it's now an extra object that has to be created. And then we immediately unwrap it again and pass it down to the next level. So that proc object is a complete waste. And if you're churning through this, and this is a hop path in your code, that's going to be overhead that you don't want to deal with. So we've got a little benchmark here that basically is just calling that foo method anytime with blocks. This is what the performance looks like for us. So CRuby 2.3 is kind of a baseline here, up at the top. This next line, the reddish line here, that's JRuby 1.7. No particular optimizations for this. Wasn't very smart about how blocks are passed and how they're wrapped and unwrapped. And it's still much faster than CRuby, but there's wasted time. Now the cool part is this very simple optimization that we made. When you're pulling in that block, if you immediately send it back out, you don't actually call it, don't use it as a proc object, we'll just send it right through. So no objects created, no waste, and it significantly improves the performance of those calls. And given the amount this is used within Rails and other libraries, we're looking forward to seeing how this performance pans out. So the next one that comes up a lot is defined method. Defined method's used for a lot of metaprogramming. It's used within Rails, within lots of other Ruby libraries. Just want to be able to programmatically create a method with a block of code. And so we've been working on optimizing this as well. Both CRuby and earlier versions of JRuby had performance issues because of this. Blocks have a little bit more state they have to deal with. They've got a bit more context. So it's not like just a plain old method. It has more pre and post logic every time you enter into this. So we worked to actually compile this as if it were a method. We can inspect the code, we can run our compiler passes over it, we can see that this is just a plain old body of code, we can turn it into a method, and that gives us a much better performance like this here. So here we have CRuby in the middle this time. You can see that JRuby 1.7 actually, we had more overhead for blocks than MRI. So on a small benchmark like this, or a small method that was based on a defined method block, we suffered on performance. We'd make it up if there was more code in there, but we had a little bit more overhead. Our fix that went into, I believe, JRuby 9.04 is now putting us back where we should be as far as performance. Managed to reduce that overhead, define methods basically execute just as fast as a regular, normal, defined, regular method. So the next one here, lots of people have used this pattern. As a Ruby implementer, I hate this. I totally understand the utility of it, but there's a lot of hidden cost here. The foo method in this case is expected to probably raise a method, or raise an exception, right? And what we want to do is we want to rescue that and ignore it. We're just going to say, okay, if it failed, we'll just continue on with some other value. It's okay. And an actual practical use of this is in the standard library in csv.rb. So there's a series of converters. If you turn on automatic value conversion as you parse CSV, it will try the integer converter, and then try the float converter, and then try the date converter. And in each case, if it fails, if it doesn't parse right as one of those things, it will raise an exception, ignore it, and proceed on to the next one. And that's a lot of wasted time. So you can imagine how many exceptions might be thrown for a very large CSV file. It's a bunch of waste. For us, it's even worse, as I'll show in a moment here. So we did an optimization also in JRuby 9.0.4. When we see that form, when we see that you're rescuing an exception and then just ignoring it, tossing it away, we will not generate a stack trace. We reduce massively the amount of overhead that's involved in raising that exception, and now actually significantly faster than CRuby on this particular one. Now notice you don't see JRuby 1.7 up here. Well, so CRuby is at around 12 seconds for this particular benchmark, just benchmarking rescue nil, essentially. JRuby's 7-8 seconds or so. If we look at JRuby 1.7, you can see why this was an important optimization for us to make. 340 seconds for this particular benchmark. Lots of reasons for this. The biggest one is that JVM is extremely slow to generate stack traces. All of the optimizations that it does, all of the compilation down to native code has to be unwound, and it has to figure out what that stack trace looks like. So 100,000 times more expensive than in CRuby, and it showed. So this was a very important optimization for us to make. So bottom line on performance, CRuby definitely starts up the fastest. We would not recommend using JRuby as command line tooling, for example. We have various ways to mitigate this and for development purposes be able to speed up our own startup for you a little, but definitely CRuby is the best for small, quick applications or small, quick commands. But JRuby does run the fastest. If you have an application that is not running faster and often significantly faster on JRuby, let us know, because it's almost always a bug or something that's broken. JRuby should be fastest at running just about every piece of Ruby code that's out there. And the best part is we're just getting faster. With the release of JRuby 9.1, we'll be caught up again on compatibility. The next 6 to 9 months are going to be performance. We're going to have a lot of fun with that, and hopefully some of you will come along for the ride. All right, so concurrency-wise, let's talk a little bit about this. And really what I'm talking about here is parallelism. And this is a very subtle distinction that I think is worth talking through. So what do I mean by concurrency and parallelism? Well, parallelism is what happens essentially at the hardware level. You've actually got two processors or two instructions that are actually executing at the exact same moment. Most of the time you don't notice this fact. Various libraries will multiplex threads. CRuby has threads of its own, and you don't notice that you're not using all the cores. But this is the hardware level, is what we're talking about with parallelism. So concurrency is at the software level, at the programming level. You write with a concurrency API of some kind. Doing thread.new, using actors, having a pool of executors that's going to run through some work, background jobs, things like that. That's what we talk about with concurrency. And both JRuby and CRuby have a concurrency story, but only JRuby actually gives you concurrency and parallelism. So you can actually use all the cores in your system. So last year I did a few talks around the world at various Ruby conferences on bringing concurrency to Ruby, what we're doing to fix this stuff up and make it better. There's libraries like ConcurrentRuby, which is now a dependency of Rails. All sorts of concurrency utilities that never existed for Ruby before. This has all come around because of JRuby, because we really believe that Ruby needs a better concurrency and parallelism story. And we're doing a lot of work here. It's gotten really exciting over the past couple of years. So let's talk about parallelism. So in CRuby, you can get parallel execution, but you pretty much have to do it at the process level. Ruby threads can't run at least Ruby code in parallel at the same time. Sometimes at the C level, it might release a lock and be able to call out some native library while the Ruby code's running. But in general, you're only ever going to get one core's worth of work out of a given CRuby process. In JRuby, of course, thread level parallelism, it's real threads, real native threads at the operating system level. The CPUs all will be burning away. They'll be working through it. So let's take a look at an example of this. I found a little example online, this Ruby concurrency and parallelism practical tutorial blog post from a few years back. And this is an example of what would it be like if we had a number of jobs that we wanted to run in parallel. In this case, sending out a bunch of emails. And then some processing involved in each of those emails. But we'd like to be able to use all the cores in our system to get this done as fast as possible. So here is the single-threaded version of this benchmark. 10,000 times by default, we're going to deliver this mail, just to see how much parallelism we can actually get out of the system. This is the more complicated threaded version. So here we have a pool of threads, a certain number of threads, probably about this. Usually you want to do the number of cores you have in your system. So I did 4 for my running of benchmark. And then just feed all of those jobs into those threads. Let them crank through it as fast as they can and see how long it takes for us to do this. So in CRuby, as you'd expect, we have the single-threaded version here. No matter how many threads we throw at it, we're not actually going to improve the performance. It's still only going to give you that one core, one thread's worth of work. And in fact, it's actually a little bit slower. The overhead of the threads actually starts to slow things down a bit in CRuby. Not a tremendous amount, but certainly not getting any sort of gains. Now we can fork this off, and for some types of jobs, some types of work, forking is okay. It's easy enough to parallelize. You don't have a lot of communication between threads, you don't have a lot of shared memory, and it works all right. So you can get to that point of getting parallelism with Ruby if forking works for you. Of course, in JRuby, we can actually use threads. So here's our single-threaded version. And here's our actually 4 threads on my 4-core system. And this works out in both cases to be roughly 3 times faster. So there's always a little bit of overhead, there's more memory use, the memory pipeline gets a little saturated sometimes, but generally you can get some semi-linear improvement in performance if you use threads or forks on JRuby. But generally threads are a little bit easier. You don't have to worry about that communication between processes. And more importantly, you don't have to worry about all of those processes taking up memory and using the resources in your system. But see, the thing is, we always hear about threads being so bad. That's dangerous. We don't want people to be using threads directly. But the truth is that most of you will never have to do thread.new. Libraries like ConcurrentRuby, servers like Puma, frameworks like Rails and Sinatra, they take care of most of that parallelism internally for you. So if you just throw it onto a parallel implementation like JRuby, most of the time you're going to be able to get the advantage of having multiple threads and actually using this. And more importantly, you'll be able to deploy one Rails instance for an entire machine, an entire site. We've heard some amazing stories about these cost savings. So I say here, you'll cut your instance count 10 times or 100 times if you can make better use of the system. We actually had a report from someone that took an application deployed on EC2. They were using 35 extra large instances. And if you do anything on EC2, you know that that is a lot of money to be spending month to month. 35 extra large EC2 instances down to 10, I think it was mediums. They saved, by moving to JRuby and doing a week or so of transition work from CRuby to JRuby, they were saving tens of thousands of dollars every month just by making this move. So this is a huge win. And this is where true parallelism in a Ruby runtime really pays off. So generally, the libraries and frameworks are going to do the thread docking for you. There's a lot of work to make better concurrency utilities out there. And on JRuby, you're going to have better, more efficient apps, better use of the hardware, better straight line performance, better parallelism across the board. So we really are convinced that this is the way large applications, enterprise scale applications need to start running. You're eventually going to get to this point where JRuby is going to help you. And so that's it, right? We can just take our code and we throw it on JRuby and we get fast performance, we get parallelism, move to JRuby, now your app is fast, right? Well, that's sometimes true. It is possible to write very efficient Ruby code. And like in Nico's talk yesterday, he showed that there's things you can do that don't even have anything to do with Ruby, that suddenly your performance will be great. Ruby is not necessarily the performance problem that you need to worry about all the time. However, it's also very easy to write slow Ruby code, inefficient Ruby code. Things like the rescue nil still have a performance penalty on CRuby. There's other Ruby forms. There's lots of these little features. So blocks are expensive, more expensive than you actually realize. A case when, in many cases, most cases that I see in the wild, it's going to be a cascade of calls to triple equals. So the longer the case when, the longer it's going to take every time you go through that. There are some optimizations we can do, but we're limited there as far as how the language works. Singleton classes, like Aaron was talking about in his keynote yesterday, very expensive, have impacts even in JRuby with all the work we've done. Singleton classes, having a lot of different objects, a lot of different types, will impact your code. All those literals, we're starting to see a move in CRuby to at least have strings be immutable by default, so that every time you have a literal string in code, it's not going to create a new throwaway object. But still, we have arrays, we have hashes. Every time you do open squiggle, close squiggle with a hash, that's a fairly large structure that has to be created, just for you to represent an empty hash. And these things have hidden costs that are hard to find sometimes. And then, of course, I mentioned exceptions being expensive. There are still libraries out there that use exceptions for flow control, and every once in a while we get an absurdly bad benchmark report from somebody. First thing we ask them is turn on exception logging, and we'll see what's actually happening here. It's almost always that if it's really bad performance. So what happens if we don't run fast enough? It doesn't matter if we run it on CRuby or on JRuby. Something's wrong with the application. It's not running the way we expect it to. So you need to know your application. And in order to know your application inside and out, how it runs, how it does things at runtime, in your production setting, with your real application, you need good tools. And with JRuby, you get all of the tools that come with the JVM. These work for your Ruby code just like they would for any of the other JVM languages. So we'll review a little bit CRuby Tooling for any folks that are doing profiling and other work out there. So you have some basic GC stats and GC tuning that you can do. Very simple things, but you can at least monitor the garbage collector, see how much time it's taking in your application. And services like New Relic will also help you monitor this stuff. It's got a lot of long GC pauses. You might need to look at how your application is working. There are some simple profilers built into CRuby itself. And there's also a few third-party tools. StackProf that will show you kind of a flame graph of where the hotspots are in your application. RubyProf, that's a faster native profiler. Perf tools can do other examination of your system. But there's a few good ones. And it's growing over time. But on the other side, JVM Tooling is JRuby Tooling. This platform has been around for 20 years now. And there is a huge wealth of tools out there for analyzing performance, analyzing memory, monitoring GC, switching to a different GC if necessary. So we've got a massive number of garbage collectors. There's 3 or 4 just built into OpenJDK that will be either parallel, where it uses all the cores to run as fast as possible, or concurrent, so it'll do most of its work while your application continues to execute. No pauses. There are implementations out there that have no pauses ever. You're guaranteed that you're never going to see a GC pause, no matter how much garbage you throw at it. Very cool stuff there. And then built-in tools. In every JVM, you can monitor the GC. You can monitor the JIT compiler. You can see what threads are doing. I'll show some examples in a minute here. Remote monitoring is a standard part of the platform. So you can, in JRuby, you can see what code's getting compiled, you can see what methods are executing, you can define your own metrics that you can publish to this JMX monitoring system. And so any tool out there that can look at the job of remote monitoring can see your Ruby application and see what it's doing. So you can keep an eye on your production apps without adding any overhead. And then dozens and dozens of tools for profiling and all this other stuff. There's many free tools, many commercial tools. If you need a performance tool, or you've ever seen a performance tool, there's a version of it that runs on the JVM, and that will work for your JRuby applications. So what I'm going to talk about mostly today, I love this thing. This comes with OpenJDK. It's called Visual VM. It's basically a graphical console that lets you look inside the running JVM, look inside your application, and see all sorts of things about what's happening, what the threads are doing, and what GC is doing, and so on. This is the main pane that you would see. This is the monitoring of CPU over here on the left. And we can see CPU for the application is up here. Here's the CPU time that's being spent on garbage collection at the bottom. Over here we can see how much maximum heap, like what the total heap size is, and how much of it's actually used. And we have our nice sawtooth of garbage collection here. And now this is a cool view. This one's even awesomer. I mean, this is an actual view of what's happening inside the JVM's GC, a live view of how it's allocating objects, how it's doing its garbage collection. We've got our young generation here where objects are being created. If they stick around, they get promoted a couple times. Here's our old generation. We can see how it's looking over time. If we are leaking memory, we'll see that graph slowly start to trend upward. And then we can actually pull off heap dumps and start to monitor where these objects are going, where they've been allocated, why are we leaking, why are we allocating so many objects here and burning up GC and object time. Very cool stuff. And this is just a free tool that comes with OpenJDK. There's also a commercial tool from Oracle called Java Mission Control. The idea behind Mission Control is that it's all of what you have with Visual VM, but you can have it running on your production application with no performance impact. Nothing will actually slow down more than 1% or so. Then you can go back to your production log, you can go back to your production recording and see what happened. We had a bad day. We had like a flurry of customers. We had a big sale. And we didn't know how the application was able to handle it. We didn't know why it slowed down. We wanted to see what the problems were. You can monitor in production and replay it. So with the Mission Control, oh, and I should mention, this is a commercial tool if you want to do it in production, but you can use this for free in development too. So most of the JVM tools have this sort of license where, for development purposes, it's okay to use. If you want to run in production, you might pay a bit more. So we take our recording, and it will monitor the JVM for a while, record in a very lightweight way what's happening. Then we get a view like this. This is a view of the various aspects of the JVM, what it's doing. Here, of course, we have our heap usage monitoring. In the middle, there's total CPU. You've got the amount of time that's being spent on GC pauses. So you can see if you're wasting time GCing. And then, of course, down here, we've got a similar graph where it'll show what's actually happening within the GC over time. This application grows a little bit, but then it behaves. It's a good application, a good simple script that I wrote. It tops off, and that's what you'd want to see in your application. Very hard to get this information out of CRuby. There's just not the same sort of tooling for it. Let's continue on here. Here's another one I really like. This is actually monitoring the allocations that are happening. So you can see over time how many objects are being allocated. You can find out where they're being allocated, and you can fix performance problems that are resulting. A little bit more on garbage collection. So the JVM GCs are also incredibly tunable. For different size of heaps, different amounts of garbage, you can make adjustments to how it actually works. Get the GC out of the way so it's not your problem, it's not slowing down your customers. There's also tools out there, free tools like gceasy.io. You give it a JVM GC log and it will look for problems and help you figure out what's wrong with your application. And then some commercial tools that can also collection analysis. Look and see what your application's doing, what you need to fix. So beyond this, now we actually want to try and find bottlenecks in our application, and that means we need some profiling tools. So I mentioned the CRuby ones. In JRuby, we have a couple command line options. So --profile is our timing profiler. It will actually give you the amount of time spent in each method body, all of your Ruby methods, and show you which ones are the hottest ones. So this is a good first line thing to see where your performance is going in your app. -- sample turns on a JVM sampling profile, much lower overhead for the system, and it gives you a kind of a coarse-grained view. If you're spending a lot of time in one method, that'll show it to you very quickly. There are also some command line profilers that are built into the JVM itself, and then, like I mentioned, many graphical options for doing profiling. So let's take a look here. This is the -- profile output for the red-black tree benchmark. And we can see up towards the top, we've got things like add, insert, and whatnot, things that you'd expect to see in a red-black benchmark. The same benchmark using the profiler that's built into Visual VM. And you'll notice that we have kind of an oddly mangled naming system over here. This is for JVM stuff, but you can still kind of get it. It's based on the path in the system, the script that it was in, and then the name of the method. So after a little looking, you can figure out what we're doing here. And then, of course, we got similar sort of stats here where you can see all of the different methods, what amount of time they're taking, where your hotspots are, and what you need to fix. All right. So that's one of the profiling tools. I recently found out about a similar flame graph library for JRuby, for the JVM essentially, which means it's for JRuby. And you can see your application from the top down and where the hotspots are and look to see what might actually fix your application and improve performance of a specific part of it. Cool stuff. Now this is all just the beginning. There's so many more tools out there, way too much stuff I can show, and so much cool stuff that's coming along for JRuby. Hopefully you'll have a chance to give it a try and let us know what you think. So let's wrap this up here. Ruby is alive and well. I mean, proof is that we're here, we're doing real applications. The Ruby world is doing great. The Ruby IRC channel on Freenode has over 1,000 users. It's one of the largest channels that I frequent of all the different programming languages. So Ruby's doing very well. And CRuby does continue to improve over time. We have great respect for the CRuby folks, Koichi, Mats, Nobu, Aaron, all the folks that are working to improve CRuby. It's shown. And CRuby has gotten so much faster over the years. We're really impressed with the work that's gone into it. Ruby 3 is also very exciting. Better concurrency, better performance, a promise from Mats that this is going to happen. I think this may be the first time that Mats has actually said performance is an important thing we need to fix. He was very much just concerned about programmer happiness, making a nice language. But now even Mats recognizes that performance of Ruby needs to get improved. But the thing is, JRuby is performance today. Right now, you can use it. JRuby is real concurrency, real parallelism today. JRuby has these tools that you need for a real application over time, managing it, growing it. And JRuby will make you happier as a result. You won't have to worry about these performance issues. You'll be able to find problems more quickly. And in general, I think JRuby is, if not the future, a very strong future for Ruby. We're going to try and keep Ruby vital and keep it strong into the future so people don't have to leave and use other languages. And that's all I have for today. Thank you very much. Thank you, Charles. Yes, I think we got a couple of minutes for questions. It's perfect timing. What do we got?
Hello.
Hey.
So you mentioned, JRuby is great, but we also saw not many people are using JRuby. So I was thinking about that. In my experience, the tools that you use, like deciding whether you want to use JRuby or CRuby, a lot of that comes from when you start. So for instance, you join a company, everybody using a text editor, and you just go on board with that. And when I see people starting with Ruby, for instance, at Railsquares or at Code Academy, from my experience, I've never seen JRuby introduced right there. So it sounds like the things you were talking about are more like, well, you work with CRuby for some years, and then you get to those bottlenecks, and then suddenly you're like, I should explore JRuby. But my question for you is, do you envision JRuby also as something that people who start can somehow say, oh, actually, I'm going to install JRuby on my machine just from the start? Is there a decision for that, or
Right. That absolutely is a goal for us. We have spent a tremendous amount of time trying to make sure that the experience of using JRuby feels like CRuby. Really, the only thing now that's a problem for us, and I'm convinced it's the sole thing that has kept JRuby from being the primary implementation out there, it's the startup time issue. We have some plans to fix that. We have some plans to work with folks at Oracle to get that fixed. But yeah, in general, Bundler works, Rails works, the servers work. Most of the libraries that you're going to use are basically going to be the same. We've also actually heard about a few places now that do Ruby training or first-time Ruby stuff, and they've had this tremendous problem dealing with Windows users. CRuby on Windows is still a bloody nightmare to work with. You've got C extensions that don't publish Win32 builds, so you've got to have compilers installed. That's just a massive headache to get all that stuff working. You can't have new users come into Ruby and start dealing with that sort of problem right out of the gate. So there are a number of training places that will use CRuby on all the Unix platforms and use JRuby on the Windows side. So it's a little bit more approachable and doesn't have some of those issues. So those sort of things happen more and more over time. How many people have seen the JRuby site? It's got like a little walkthrough tutorial. The JRuby site actually runs JRuby. Because of security aspects, because of concurrency aspects, parallelism aspects, so multiple people can be on the site using it at the same time. So JRuby is out there a lot more than people realize, trying to get the word out more and more about that. And training and introducing people with JRuby is a great idea, and we'd like to do more. Next.
Yeah. Ruby draws in a lot of people due to the gems and the tremendous library of open source stuff, and JRuby obviously opens up an entirely another world, a huge universe of stuff. I don't really have any way to get my head around it. Are there some kind of standout examples of things that we could only get through JRuby in terms of the open source?
Sure. It's a good question. So some of the examples that we keep hearing about, there's a library called Apache Poi. It's a library for parsing and generating Office documents. Nothing like this exists in the CRuby world or even in the C world. But you can just call out to this and basically build up a graph and get a Word document or an Excel spreadsheet. That's one good example. iText is another one. Excellent PDF generation library with all the latest features, heavily used all across the Java world. We have libraries like Prawn, but over time they bit rot a little bit. Performance-wise, they may not be there. Feature-wise, so libraries like iText are very popular to use in JRuby as well. And there's a number of these options. There's concurrency libraries. There's graphics libraries. We have people that do desktop applications and games. We have a Minecraft plugin that lets you write Minecraft mods in Ruby. I mean, anything that's out there that runs in Java, you can basically do something with Ruby.
I'd like to browse a page like things I can only do in JRuby just to get ideas.
That's a great idea.
Something like a collection of this type of stuff.
I agree. That's a great idea. We should have a page that shows kind of like you want to do a PDF, you want to do Minecraft. Here you go. Get some cool stuff. Thanks. Good idea. And I think we're about done. We'll move on to the next talk. If there's any more?
Yeah, I think there's time for
Anything? Question? People are moving around. Okay.
Just a quick question. What's the preferred type of Java for production? What's the version, whether it's Oracle or OpenJDK, or whether it's 7 or 8 or even 9 dev? What's the preferred right now for production?
Great question. So first of all, OpenJDK and Oracle JDK are 99.9% the same thing. Oracle JDK has a few commercial features that you might have to turn on, like some different garbage collectors. The mission control stuff I mentioned, that's only in the Oracle one. So if you want those features, you'd go with the Oracle JDK, and you can run either of them for free. We usually just recommend OpenJDK, any of the current 1.8 or Java 8 builds. Yeah, I mean, OpenJDK works fine. If you're on obscure platforms, we do work with folks on IBM mainframes, so using IBM's J9 JVM. We work with people on heaven forbid, open VMS. We've got people on these weird, old, archaic platforms that don't want to use those platforms' languages anymore. They use JRuby and they run on those JVMs. So it's generally going to, the answer to that is generally going to be whatever the best JVM for your platform is, it's going to be the best one for JRuby. And it's usually OpenJDK on anything that we're doing here. All right.
I think that's it.
I think that's it. Thanks very much.